All right, good morning, ladies. A couple things I want to talk about before we get into. So we were doing, we talked the other day, modeling of exponential equations. We talked if you graph this, all of these will cross at the point 0, comma a. And because that's our y-intercept, it's our initial value, if you will. If you see it going uphill, it's going uphill because b is greater than 1. As you're multiplying by a number greater than 1 every time. If it's going uphill, this is called exponential growth. Remember we talked about the other day how a little kid is learning how to take a pee, and you don't wash the toilet often enough. Right behind the seat there is going to get But Green, I thought his bacteria are small. Bro, they are. The fact that you can see them says how many there are. There's a lot of them. And we also mentioned, hey, listen, if it's moist and damp, those little buggers grow faster. It's, 100 degrees out and dry as a bone. They're not going to grow as fast, obviously. And so that B, in the real world, that B changes based on, hey, are we doing, what kind of stuff are we looking at? Is it a small town? Is it how fast it's growing or not growing? Or is it a big city metropolis? What's going on? What are we looking at? So that's growth. Decay is similar, except that this scenario, of course, looks like this. Ooh. And as it also crosses at 0, comma a. Okay? And it's going down. It's going down because b is between 0 and 1. Now, you'll note that b cannot be negative. Can't be negative. Because what would happen? Every time you multiply by a negative, it would go positive to negative, positive to negative, positive to negative. That's ridiculous. Okay? Number one. Number two, if you thought about it as growing bacteria, all of a sudden I had 1 million bacteria, and then I had negative 5 million. Wait, what? Well, yeah, I multiplied by negative 5, Groom. That's weird. And then the next time it's 25 million. You're like, what the heck? Well, I'm just multiplying by negative 5. That doesn't make any sense. So we don't multiply by negatives here in this case, okay? There's no such thing as that. Now, also, you wouldn't let it be 0, because if you multiply by 0, you got 0, toots. That's all there is. There ain't no mo. Also, it can't be 1. Be very boring. Hey, what is 5 times 1? It's 1. Hey, times it by 1 again. I'm sorry, 5 times 1 is 5. Times it by 1 again. It's still 5, bro. That's weird, okay? So, greater than 1 is exponential growth. Between 0 and 1 is exponential decay. Okay, so a couple things I want to talk. It does not look like decay. Decay. There you go. This, of course, has to do with, a lot of things. You could spray your bacteria and watch them die. You could talk about, so like say you sprayed some weeds out in the field, and every hour or two, a certain more of them percentage of them died off. Okay, anything like that. I used to do this thing where we made ethanol, aka moonshine, in my physics class. And when you're boiling the water, there's water and alcohol mixed. You boil it, the alcohol evaporates first. So the amount of alcohol that's left in that pot over time will get less and less and less. In other words, it's decaying. Hey, if you put a pot on a stove and you let it boil, and there's steam coming out, Groom. Mr. I went back there an hour later and there's no water in the pot. Well, duh, you boiled it all out, you goofball. But what's happening is that you're decaying how much water is in the pot. It's not a linear. It's not like you're losing 2 ounces every minute. You're losing a different amount as time goes on. Okay? Exponential decay. Now, a couple things come to mind here. Well, I want to talk today, first of all, about properties of exponents. Now, some of these you've seen, and so some of this will be review for you, and some of it will not be review. Some of it will be hard. Like, wait, I've never seen this before. It's not rocket surgery, kids. When you times, it's just x to the m plus n. Why? Because x squared times x to the 5th is the same thing as saying x times x times x times x times x times x times x. How many x's are there? That's right, there's 7 of them. Okay? It's a big deal. This is a big deal. We will use this thing a lot, and for the most part, most of you know that one, I think. X to the m over x to the n. The way I was taught and the way most books teach it is you take the top minus the bottom. And that's true. That is true. But I like to make it a little easier on you. So let's let's see what happens here. If you did this and you said, oh, okay, well, that's cool. What if I had x to the 6th over x to the 4? What Mr. Groom always does is, who's got more, top or bottom? Come on, tell me. Are you saying it? I can't hear you. Come on, Brooke, I can't hear you. It's the top. And so what we're going to do is we're just going to go 6 minus 4 is 2. So what we have left over is on top. It's x squared, or just x squared. If it's the same problem but upside down, okay, who's got more? Oh, poop. My pen quit working. Whoops-a-daisy. Oh, I pissed her. Oh, there, I pissed her off there, didn't I? Yay, x squared. Or x to the 4 over x to the 6th. Groom, it's the same thing. Not quite, senorita. The bottom has more. How many more? 2 more. So it's 1 over x squared. Remember up here it was 1 x squared over 1. This is just x squared. This is, well, it's not x squared, Groom. It's different. Okay, well, if you follow the pattern, 6 minus 4 up here, 6 minus 4 is 2. 4 minus 6 is negative 2. So when we do these, x to the negative m, any power, doesn't matter what it is 1 over x to the m. We're going to do a ton of that. So if you've seen it before, cool. If you haven't, let's commit it to memory now. Okay? We got to know where we're going with these things. Okay? Another one that comes along is x to the m to the n power. In this case, you multiply your exponents. And so what do I mean by that? Well, I mean, what if I had x squared and I cubed it? Well, that means x squared times x squared times x squared, which is x to the 6th. Oh, you mean 2 times 3? Exactly. We call this a power to a power. It's kind of a big deal. Let's say you had x to the 12 divided by x to the 12. Everybody knows that's 1, Groom. Anything divided by itself is 1. I agree. However, when we have exponents, what do? You subtract them, and I get x to the 0. By definition, anything to the 0 power is always 1. Always, always. Always, always. Okay? Always. All right? So that's going to be a big deal. Now, a couple things. So we're going to be doing some of these guys today. We're going to be having a little fun with it. It's going to be a good time, and so forth. So if you had, I don't know, x to the 6 times y to the 10 over x to the 4th, y to the 12. Hey, Groom, what would that simplify to? Well, let's start with our x's. Who's got more, top or bottom? Top does, Groom. How many more? 2 more. Who's got more y's? Bottom. By how much? By 2. Done. Circle, dot, dot, dot. Your answer. Do another one. Okay, all right, fine. Dude, check this out. 64x squared y p to the 3rd. What? Now, what about the 100 and the 64? I don't know what to do. Listen, what do you know goes into both of them, kids? Hey, I know. 4 does. Oh, nice. 4 goes into 100 25 times. 4 goes into 64 16 times. Can you reduce anymore? Nope. Let's look at our x's. Who's got more x's, top or bottom? Bottom. How many more? 1 more. Who's got more y's, top or bottom? Top. 1 more. What about z's? Bro, the only z's on top. Well, then it has more, yes? Duh. Who's got more p's, top or bottom? Well, only the bottom. So, p to the 3rd. Boom, 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 boom. Done. That easy, man. That easy. Okay. And we'll do several of these. It's fun. We'll do some more. Calm down. I got you. Bro, I got you. Just stop it right now. Now, suppose you had this guy. Oh, I don't know. 60 C12 B6 Z11 whatever 70. Stupid computer. I hate you. I hate you. Bro, I hate you. Just start. Well, poop. Well, poop, poopy doop. All right, I'm gonna try another one. 60 p squared z h 11. Nope, nope, nope. Okay. So if you're dividing on this guy, hey, look, what goes into 60 and 70? 10 does, Groom. I know, 6 and 7. Who's got more p's, top or bottom? Well, the top has 2. The bottom has 1. So p. Z to the 5th on the bottom because it has 5 more. Remember, z is just z to the 1st power, of course. Q, leave it alone. And h to the 9th. Nice. It's not very hard. You got this. Okay? Now, should we do a little timesing? I suppose we should do a little timesing. 2x, y to the 3rd, z times 5x squared, y, z to the 4. Bam! Hey, Groom, what's 2 times 5? What's 10, kids? What's x times x squared? Well, let's see. I'm adding exponents. So x to the 1st times x squared is x cubed. And then y cubed times y is y to the 4th because there's now 4 of them. Remember, we're doing y times y. There's 4 of them now. And then, of course, z, add your exponents, z to the 5th power. That's it. I wish I could make it harder. I cannot make it harder. Wait, maybe I can. Oh, friends. Oh, dear. There you go. Oh, Q to the 4. All right, let's times, baby. 6 times 2 is 12. A squared is all I got. What about my b's? Well, I got a 1 here and a 7 there, so b to the 8. This is c squared times c to the 6. That's 8 c's. Now check this out, yo. Q to the negative 2 times q to the positive 4. We are timesing, so we add our exponents. That's negative 2 plus 4 is positive 2. Another way to write this problem initially, and we're going to talk about that in a second, we could have written it as a fraction. Maybe that would have helped us. Maybe it made it worse, but maybe it would have helped us. Okay? So I'm going to see what I can do here in a second. I'm going to do a different problem here. Suppose you had this guy. Oh, Groom, I'm scared. What's going to happen to us? Oh, no. Oh, no. No, gross. I don't know what's going to happen to us. It's terrible. Let's times them, baby. Now, there's 2 ways to do this problem. If you were good at fractions back in 5th grade, we could do some cross canceling. Maybe you remember that. If you don't, just forget about it. Multiply the top. Okay, you can do this 2 ways. So you could either times all the way across the top, and if you did, you'd get 21 x squared y to the 4 z to the 5th over 12 x cubed P14 Q8. You with me? And then, of course, I can reduce that because what goes into 21 and 12? 3 does. So 7 and then 4. And then who's got more x's? The bottom. And you're home free. That's one way to do it. Another way that some people dig, but I don't know if I like it or not in some respects. Sometimes you can reduce your fractions here and here. 7 and 12 don't reduce. Y and x don't, and so forth. This case here, it wouldn't have done any good to do that. So I prefer, for most kids, just multiply across the top, multiply across the bottom, and then go to simplifying. It makes your life easier. Okay? Now, what if we did this guy here? Now remember, Groom is not here to help you today, so don't panic. Don't cry. Groom's got you. Oops. So we're going to times these guys. Okay. Now, in this case, you can reduce 14 into 16, yes? But in a minute, you're going to have to multiply across anyways. It's up to you how you choose to do it. I'm only going to model it today by multiplying across the top. I just find that maybe this will cause less headache for us. So 21 times 14 is 294. Okay? X to the 7 times x to the third is x to the 10. G9. But what about my y? What about it, sir? There it is. What about my p squared? And what about my z squared? Bro, they're right there. Look, calm down. Now, if I do 16 times 28, I get 448. That's a big number. All right, let's go to work, friends. Okay, let's start with the easy stuff. We'll take the win. How many x's? Well, there's 9 more on top, so there we go. How about my g's? Well, there's 2 more on top. What about my y's? Well, there's 6 more on the bottom. What about my p's? There's 2 more on the bottom. What about my z's? There's 1 more on the bottom. I think that covers everybody. 1, 2, 3, 4, 5 variables. 1, 2, 3, 4, 5 variables. Sweet. And now, what goes into 294 and 448? Well, you know 2 does. So that's 147. I'm going to do it over here just so I don't can waste time. And then 448 divided by 2 is 224. 224. Obviously, 2 doesn't go in anymore. Neither does 3. I think we're done there, friends. 147 divided by 224 is... Oh, nope, I lied to you. I lied to you. 7 goes into both of them. And 7 goes into there 21 times, and 7 goes into there 32 times. Yay! And that's my answer, kids. That's it. That's all there is to it. Okay? Nice. Now, I'm going to have a couple of these on the assignment to see if you're paying attention. If you're paying attention. So, I am going to ask you this equation. 1/6 to the minus 2 power. What do I do with it, Groom? Well, what does it say? Listen, negative. And a negative exponent says, check this out, a negative exponent. I'm sad. Make me happy. Okay, how do I do that? Well, I put me in the basement and then I'll be happy. Whoa, that's cool. Now he's happy. His frown went away. Now, what if you had 1 over x to the minus n? Listen, I'm in the basement and I am not happy about it. Well, come upstairs. Oh, I'm happy again. Do you see that? So what we're going to do is that negative just flips us upside down. Wait, do you mean that this is equal to 6 over 1 or just 6 squared? That's exactly what I mean. But that's easy. That's 36. I know. That's it. Can't you make it harder? No, I can't. No, sure can't. So what if you had this guy? 7/3 to the negative 3 power. Well, let's flip it first. So 3/7 to the 3rd power. Now, when I do this, it's going to be, this is the same as saying 3 to the 3rd divided by 7 to the 3rd. So that's going to be 27 over 343, of course. That's your final answer. Okay. Groom, could I have done this first instead? 343 over 27 to the minus 1. That is, could you have raised it to the third power first? Yes. But what does the negative tell me to do? It tells me to flip it over. Okay? That's it. That's it. So we're going to be talking about that today, and it's going to be very fun. Very fun on the homework, okay? Now, the last thing I want to chat about with you before we go, and I'm going to give you some homework. There'll be an assignment for you. I think Mr. Ross is going to give it to you. I want you to use... I'm going to give it to you. Yeah, Mr. Ross will give it to you. It's a worksheet. Don't... Just take your time, get it done. Hopefully you should be able to work it out most of the way in class today. Okay? And we'll chat about it next time when we come to class. We'll kind of go over it together a little bit. Normally, I don't like to give homework like this exactly when I'm gone, but that's okay. It's not a big deal. Now, I give an assignment, but I'm not. I like to be there when I give an assignment out so I can answer any questions initially. But I got a question for you. So the other day we did this equation, something like this: 2 times 3 to the x, a Skittles, if you will. Yes. And we did these tables like this: x equals 1 and y equals 0. 2, 1, 3, 2, no, come on, you jackass. We're going to times by 3, so if there's a 1, 3 times 2 is 6, attaboy. We times by 3 again, that's 18. We times by 3 again, that's 54. We times by 3 again, and it's 162, obviously. And so on and so on and so on. Look at this, every time. What is 162 divided by 54? 3. What is 54 divided by 18? It's 3. What's 16 divided by 8? It's 3. What's 6 divided by 2? It's 3. That pattern right there, where you're timesing by the same amount every time, that is a dead giveaway that you're looking at exponential growth. Okay? But here's my question to you. Suppose x was the number of years your money was in savings account. Question. Suppose you put some money in the account 6 months ago. Are you going to get interest for part of the year? Yes, you are. You mean like half of the year, Groom? I mean like half of the year. Wait a minute. Groom, you didn't do any of the in-between numbers here. Can you raise things to a power that is in between 2 and 3? You sure can. Let me show you. Suppose I ask Betsy here. Oh, Betsy, what is 2 times 3 to the 2.5? It's a number. And look at that number. It's a number somewhere between these guys, isn't it? You with me? It's between 18 and 54, isn't it? You see that? And if I made that 2.7 or something, it's getting closer. It's going to be closer to 54. You see that? And let's try again. Oops. There you go, baby. Does that make sense? So when we start doing these guys, what you're going to see is that when we're plugging and chugging numbers by hand, we're using whole numbers. And that's fine, I guess. But in the real world, there's always going to be in-between amounts. Okay? If you spray some Lysol on your bacteria and it starts dying off, it doesn't just, it's like, okay, and now everybody die right now on the hour. That's weird. People are dying, the little bacteria are dying all the time. Yes? And so that's something to keep in mind. And then the question would be then, well, what do those mean exactly? What do you mean? Well, those decimals, I mean, what do they mean exactly? Oh, that's a good question. Yeah, it turns out, have you ever seen this guy before? The square root function? The square root is x to the 1/2 power. This is equal to the square root of x. Okay? What? Well, listen what it means. Now, we're not going to do any of these today, but I am building to something here. You with me? So what number times itself is equal to x, this value? You with me? So for instance, what number times itself is equal to 36? Well, 6. So 6, we say, is the square root of 36. And so next time we meet, we're going to spend a couple of days talking about this. We're going to take 6 squared, which is what 36 is. 6 squared to the 1/2 power. Well, 6 squared to the 1/2 power, this is a power to a power, so you times your exponents. What is 2 times 1/2? It's 1. So 6 is the answer. So we're going to spend some time with that. And you're like, so that's 0.5, Groom, I get it. But what about 0.3? What about 0.4? What about all these other ones? They're similar scenarios. We're not going to get involved in it a ton, but they're similar scenarios. Okay? So something that we're building towards in the future, 2 to some power is equal to 51. Do you see that? There is some power of 2 that you can raise it to get 51. Well, 2 to the 0 power, of course, is 1. 2 to the 1 is 2. 2 to the 4 is, oops, you dummy. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6th is 64. Dude, 51 is somewhere between those two values, yes? Groom, are you saying that if I took 2 to the 5.5 power, I would get 51? No, 5.6, maybe 5.7. 5.65. Oh, not quite. 6.8. Oh, oops, 6.7. Ooh. Yeah, basically 6.7. You with me? 6.72. Oh! Now, that's the fun part. So we are building towards something, okay? Remember, we talked about this the other day. There's going to be a time when I'm going to want to know when. That's often a time up there. When are we going to know? When is this thing going to equal 51? Okay? And it would be about, if these were in years, it would be about 5.674 years. That's when it would be there. You with me? This is what we're building to. Okay, and so this idea of why do I need to know my exponent powers better? Because it's going to help you a lot going forward, but it builds towards what we're doing. Okay, this is huge. Once you understand it, you're just like, oh, duh, oh, duh, oh, duh, and we're done. Okay, it's that easy. Okay, so your homework assignment, I'm Mr. Ross, give it to you. Go ahead and do it. We'll just hang on to it until I see you next week. Bye.